Welcome to SCOMAthon 2024. My name is Nathan Gau, and I will be doing this presentation on SCOM Managed Instance and Security. I think most of you know me by now. I've been working in technology for 25 years across a number of industry verticals. The last 9.5 years of my career I've spent at Microsoft, although I was recently let go. So same shameless self-plug. If you're looking for a security architect or for someone to do some consulting for you, I'm actually a free agent and more than happy to do that. You will find my work on my blog at nathangau.wordpress.com, and that's still up, although admittedly I haven't really done much work on the blog here in the last couple of years, but everything I've written for the SCOM management pack, as well as turning SCOM into an edge device for Sentinel, is all still up there, along with the appropriate pieces for this particular presentation. I've got some links off of my blog that you'll see here shortly, or actually on this slide. So the parts from my blog are those multiple parts article, the securing SCOM in a tiered access model, and then the cybersecurity for the IT professionals. That's the second one there is really designed for you, the average IT professional, not really for the average security professional. And then the first one, securing SCOM in a tiered access model, is really for it's really the only public white paper on securing SCOM, and it's a really good piece if you want to kind of look at how to secure your SCOM environment. There's a lot more detail in there than what we're going to cover in this presentation. I've also included links to the Microsoft Cybersecurity Reference Architecture, which is always changing, so it's a good piece just to pull down and keep an eye on periodically, as well as an overview to SCOM Managed Instance, and then an overview to Key Vault, which is something that's unique to SCOM Managed Instance and something that you may want to take a look at. With that, we will switch into the SCOM Managed Instance architecture. This picture is right off of Microsoft's documentation for SCOM Managed Instance. There's actually really two pieces of SaaS architecture here. You've got SQL Managed Instance and SCOM Managed Instance that you're going to connect together to form a SCOM Managed Instance that you can use to manage your server infrastructure, whether it's on-prem or in the cloud. To be honest, there's not a ton of security benefits to this. It's really more administration headaches that you get to not have to deal with. Plus, if you're trying to go on a cloud journey and start moving your infrastructure into a cloud, this is a way to get your SCOM infrastructure into the cloud. Moving a lot of that management pack knowledge, you can move that directly into the cloud and start managing it there. Obviously, there are some benefits, right? We don't have to deal with server patching for SCOM infrastructure. Same with the database patching, which that was always a bit of a pain, and that's all gone. Everything also now moves to group managed service accounts for my Action account, and that's all managed via Key Vault. I no longer have to have a process to manage where those passwords are stored, those kinds of things. It's just all stored in the ether, and it's just one less thing for me to worry about. The security drawbacks, to be fair, they're not really unique to SCOM Managed Instance, and I want to make that part real clear. This is a security drawbacks that's been there from SCOM from the beginning, and they're true really for any kind of management or monitoring tool. So I don't even want to say this is unique to SCOM. Any kind of management or monitoring tool are going to run into similar drawbacks in that. One, SCOM hosts credentials. And so because of this, if you don't distribute your credentials properly, that can lead to credential theft. This problem doesn't go away switching to SCOM Managed Instance. Likewise, your SCOM agent is an admin, and that can break the tier model depending on your design, and a compromised SCOM administrator can compromise your entire environment. This is going to be true with SCOM, SCCM, Big Panda, Big Fix, any of these other monitoring tools that you have in your environment. However the design works, whenever you have an agent-based design, those agents typically run a system that effectively makes them admin, and a savvy attacker can take advantage of your system. This other little miscellaneous piece in here does have a bit of a security implementation when you think about it, but can be corrected via design. You just have to be careful in your design. But because their database, your data warehouse, and your SCOM instance are all cloud hosted, your agents are going to have to connect via URL filtering. You think about it, the agents are endpoints. They're going to connect to a service that sits in the cloud. If everything's sitting in the cloud, that can kind of be done on the backbone, and for the most part, that's not that big of a deal. But if you're still in a hybrid on-prem type situation, operating out of a data center or some sort of shared storage that's not in your cloud, you may need to set up URL filtering. What you don't want to do is just do blanket internet from your endpoint to the internet. Next thing you know, somebody can also get to Facebook. or Google or something along those lines, and then you're running the possibility that somebody signed on locally to your server and they can directly go to someplace to potentially unintentionally infect your servers with malware, or intentionally if it's a bad guy. With that said, we're going to move to the tier model and credential theft. For most of this presentation at this point, I'm actually dusting off the presentation I did in 2021 for SCOMathon, because this all really still applies to SCOM. But we're going to talk a little bit about credential theft. And the point I really want to drive home here is that attackers don't guess passwords, they steal them. And core security architects, what they'll love to do is say, well, we'll just make your password more complex and add more continuous characters and all that other kind of stuff. And look, I'm not saying that, a complex password's a bad thing, but at one point it doesn't really do any additional benefits, because the attackers really don't care if you have 1,000 characters with 50 special characters and all sorts of caps and lower cases and all of that, because at the end of the day, they're just going to steal your password, or they're going to steal your Kerberos ticket, and they don't need the password. They don't need to know it, because this tier model and stealing credentials is what they're really all about. And when you mix your credentials, your administrative and your non-administrative credentials, and you go across tiers, that's the vulnerability that's exploited in nearly every data breach. When you think about ransomware, or you think about typical data breaches, that's what happens. The attackers get in at a lower tier. They eventually find themselves into a machine that happens to have an administrative credential that's in use. They steal that administrative credentials, they elevate to a higher tier, and they're off to the races doing whatever it is they came in to attempt to do. Now this slide here, it's kind of a cheesy slide. It's an old slide, and it's definitely an on-prem slide only, but it's just something I took from one of my old MCS slides from my time there. And the cloud model is going to be slightly different in that the tier 1 and 2 layers can kind of meld a little bit, and it's not quite as split up as this. But tier 2 really consists of the wild, wild west. That's the end user layer. That's where all your client PCs are stored. That's where I do my Outlook, my Word, my Excel, my PowerPoint, all my productivity type things. Tier 1 is my data tier. Tier 0 is my identity tier. And this is your traditional on-prem environment. Cloud does look a little bit different, but these concepts are still relatively the same. What you want to avoid is the ability for credentials to move between tiers, or to be used on a lower level tier to access a higher level tier. I will tell you, as a security architect, it's definitely safer to move down than to move up. But even when a credential moves down, an attacker can still steal that credential and then use that to move laterally, which is not a good thing either. So this is kind of how that tier model is to look. Ideally, you want to have barriers in place to move down or up, and design in place to effectively make sure that administration is only done at that layer. That's where you get into that concept of a privileged access workstation, or a hardened privileged access workstation, so to speak, that an attacker can't necessarily jump to, and that I'm not using productivity credentials on. So the thing to keep in mind when it comes to credential theft, it's almost always occurs at the machine layer. Attackers don't care if the machine is physical or virtual. I cannot resolve credential theft issues by simply RDPing to an AVD system and then doing my administration from there. It does not work that way. The credentials can still be swiped. You're at risk anytime an administrative and a non-administrative credential is used on the same machine. Once an attacker has gotten a beachhead into your environment, which they're going to do through some sort of phishing attack, right, which they'll do in the tier 2 environment, and they don't necessarily need to hit the IT guy, they can hit Joe the janitor. Doesn't matter who they hit. Once they hit somebody, they're going to try to target the tools that you have in your environment. So typically your management tools. Since we're here at a SCOM conference, they're going to look for things like SCOM and SCCM, since everybody here is a System Center customer in theory. But it doesn't have to be System Center. They're going to go for the tools that you have in your environment because they want to live off the land and basically camouflage themselves as best they can. So my conclusion here, we want to design to mitigate against these vulnerabilities. And this is where SCOM comes into play. SCOM MI, same concept, right? SCOM is a very powerful tool, and the attacker has a wide range of options at their disposal. And I'm just going to say this right now: if they own your SCOM environment, they own you. What your average SCOM administrator may not know is that even though it's not exposed via the API, I can install software via SCOM just like I could via SCCM. I I can do it via a management pack. I'd have to write the management pack to do it, but it's something that I can do because SCOM has an agent. The agent runs a system, and I can execute PowerShell scripts that could connect to a remote location and install software, all as an administrator, as an example. So even though it may not be as intuitive as, say, SCCM, which was designed for that purpose, I can do this via SCOM. So we start thinking about this in terms of how we tier out our data and how we protect our data. We need to understand that SCOM is just as important to protecting an organization as a tool like SCCM, even though an attacker will probably have a preference for a tool like SCCM, because the accounts in SCCM are probably more powerful. So back to SCOM's role, it has run as accounts. Those are credentials. Now, while an attacker may not be able to just go straight to the SQL database and enumerate the username and password, they can still reuse those run as accounts if they own your SCOM environment. Think that through. SCOM also uses an agent, and that agent is an administrator over any server that runs on it, that it runs on. That's also a very important thing to consider. Excuse me. In most environments that I've consulted in, typically your SCOM instance or your SCOM managed instance is going to manage both tier 0 and tier 1 systems. And what I mean by that is that I'll pop open the SCOM console and I'll see a SharePoint server and I'll see a domain controller all being managed via the same SCOM instance. Sometimes I'll even see desktops. Now, the actual agents themselves can't really be used to compromise the SCOM server, at least not to my knowledge. But if I own the SCOM server or the SCOM administrator's credentials, I now have the ability to go into the agents and I now effectively control the machines that SCOM has an agent on. Because, to my last bullet point, SCOM can execute scripts, we can install software, enable disable services, I can use it to establish persistence, cover tracks, so on and so forth. Basically, I can use SCOM as an attacker to do whatever I'd want to do as an attacker if I know how to use it. So my conclusion, if they own SCOM, they own you. And we need to think about designing SCOM with that in mind. So design principles. The first 3 are unique to SCOM. It doesn't matter if you're using SCOM MI or not. The last one is definitely going to be a SCOM MI, SCOM managed instance only thing, and that has to do with Key Vault because that's related to SCOM managed instance. What we need to do, we need to secure our run as accounts. We need to secure administration. We need to separate our tiers. And then in the case of SCOM managed instance, we need to think about securing Key Vault. Securing run as accounts. So granted, this is not SCOM managed instance, but from SCOM 2012 to 2016, your run as accounts could run locally on a system. That means if I compromise the run as account, I could actually literally reuse it to log on to another system if it had the rights. And that was that. From 2019 on, and I am assuming SCOM managed instance, even though I have not tested this, but I would assume this would be the case. The SCOM run as accounts are going to be required to run as a service. What that effectively means is that I would have to log on locally with another account, and then I could use the credentials from SCOM managed instance, or from my SCOM run as accounts, I'm sorry, in the permissions that came with it. The credentials are still stored in memory, they can still be swiped, and they can still be reused, and that's what this point in red is emphasizing, is that you still have a risk of exposure from these run as accounts. So when it comes to securing run as accounts, we need to think about how we want to do this. The first one, I cannot emphasize enough, never, ever, ever, ever use less secure run as account distribution. What you're doing in this situation is you're distributing that run as accounts to every single machine in your environment that has a SCOM agent on it. Which means if an attacker compromises any one of those machines, they can swipe the credentials from memory from that machine. If that account has permissions, anything, which it would because you're distributing it, right? They now have whatever that account has permissions to. So one of the dangerous things an organization could do, less secure distribution to a run as account, let's say a server admin on all of the servers in your environment, because that's easy. It's also easy, it's very insecure. One server in your environment gets compromised, they can steal the permissions from that run as account, and congratulations, your entire environment is now compromised because they own those credentials. They can use it for their ransomware attack, they can use it for their data exfiltration, whatever it is they want to do. Second, always use least privileges for run as accounts distribution. So I'll highlight the SQL management pack as an example. There is a least privilege way to do SQL monitoring in SCOM, and there's a high privileged way to do it. Use the least privileged way that is just a database reader. You don't need to be a database admin to do SQL monitoring. Is it a little pain to set up? Yes. Are there some quirks associated with it? At least there were when I was a SCOM guy, but for the most part, they were pretty minor. But I would highly recommend doing that. If a SQL server got compromised and that run as account is therefore compromised, what have you done? You've given the attacker something that has read writes to a SQL database. You're probably already in trouble at that point in that a SQL server has been compromised. There's probably other accounts they have access to, but it's not this account. It's one less place that they can use. For administrative run as accounts, it really needs to only be administrators and the servers required to use them. So I will switch to the SharePoint management pack as an example. SharePoint, I'm not a fan of this design. I really hope Microsoft corrected it, but to be fair, I have not been doing a lot of SCOM work for the last few years, so I don't know. But last I looked at it, you had to be a farm admin, had to have admin rights on the SharePoint server with the SharePoint run as accounts in order to get that management pack to work properly. Make sure that that account is only able to access the SharePoint servers. And potentially, obviously, it's going to need rights to the SQL server as well, just that SQL server and whatever rights it needs and whatnot. If that particular account that you're using has more rights than that, what that happens is if your SharePoint server is compromised, guess what? They get that account. They can reuse that account on those other servers that it has rights to. Last but not least, frequently audit run as account distribution. I have walked into environments personally where I look at run as account distribution and say, oh, how did this happen? I think the worst one was when a SCOM run as account was distributed in that first one with the less secure, and turns out a red team had found it and was reusing it. Thankfully, it was just a red team. And we, of course, immediately corrected the problem before they notified us. It was something that just showed up on a security alert from a SOC. But one of those deals where it's like, we don't know how it got set to the less secure distribution. I never advised my clients to do that, right? But at the same time, it happened. That's what happens when you have multiple cooks in the kitchen. Sometimes things like that happen. And nobody was auditing this. And that was a failure on my part because I wasn't even in there looking at that constantly. We were doing other things when I would come in, right? We didn't look at that frequently. And fortunately, it was just a red team that found it. It wasn't anything serious, and we were able to correct the issue. But if it had been a bad guy that found that, right, now you've got a bigger problem. Securing administration. All right, so I mentioned this before, but it goes without repeating. SCOM agents run a system. That effectively means that they are administrators of the systems that they are monitoring. That also means that SCOM administrators can pretty much do whatever they want to your environment. If you look at most management packs, they have lots of tasks available that you can already do. Some management packs already enumerate some pretty powerful things that an administrator could do. What that also means is your SCOM admin may not be a server admin throughout your environment, but through SCOM, they effectively are. They have the ability to extend their reach, so to speak. SCOM users, I would add, just regular old operators, can also execute those same tasks if, depending on the specific management pack design that they have access to. So when you start thinking about administration, you need to think about how you're going to hand that out. Your SCOM administrator effectively is a global systems administrator because they could literally write a management pack themselves to give them access to whatever they want on systems that they monitor. And then a SCOM user can do something like, say, take a database offline. At least that was something that they could do in the SQL management pack at one point. Or you might be able to just enumerate a command prompt on a machine or a PowerShell window on a machine, and you basically have access to an administrative PowerShell that you can do whatever you want if you know how to write the PowerShell. So when you're thinking about securing administration, you need to think about what you're giving your actual SCOM administrators and your SCOM users rights to. So when it comes to SCOM administrators, SCOM administration in general, I highly recommend that all SCOM administration should occur through a dedicated administrative workstation. This can be kind of painful because this is actually a separate workstation. I do recommend this. I know Microsoft recommends this when it comes to administration. You really don't want to have credentials shared on the same machine, because what happens is when that machine is compromised, the attacker now has access to the administrative credentials. Now, there are some mitigations for that. You can have MFA, out of band MFA, I should say, that can really help you get around some of those issues. And that, I've got something that authenticates to, say, a phone, right? So I've got the separate device that's sitting in my hand or whatnot that that I have to use. That's definitely a way to get around that, but they still have my password, right? And so now they need to go get the second device. Obviously, role-based access control for SCOM administrators and remaining IT staff makes sense. You know, your operators may never want to use those tasks. That's fine. And it's up to you to decide if it's worth actually doing that extra or worth going through those exercises or not. But do understand that an operator has access to whatever you've given them rights to, and it's worth actually reviewing the management packs that they have to make sure that there's not something in there that you might say, this is not a good idea. Separating tiers. So as I mentioned previously, right, the presence of any agents on any tier effectively grants a SCOM administrator control over that tier. At that point, an attacker can use this control to acquire additional resources in that tier. So think of it this way: if I have a SCOM agent on one domain controller in that environment, the SCOM, an attacker can compromise that domain controller. At this point, they already own your identity store on an on-prem environment. And they can also compromise every other domain controller in their environment if they want. They could use it to compromise your certificate servers if you treat those as a tier 0 asset. They can pretty much compromise anything in your environment at that point, right? They own that tier. So the recommendation here, obviously, would be to ideally separate SCOM instances, but that means you're running 2 SCOM managed instances or 2 SCOM regular instances. Now, admittedly, that can be kind of a pain. So it's up to you if you want to decide if you want to do that. But if you're not going to do that, then what I would highly recommend you do is treat SCOM as though it is a tier 0 system. And you want to start thinking about how you want to use run as accounts, avoid them at all costs, other than specific least privilege accounts. You certainly don't want to use the global distribution of run as accounts, but I would manage SCOM as though I was managing a domain controller at that point, because SCOM has access to your domain controllers. Last but not least, Key Vault. So Key Vault is effectively the Azure version of your LSA. So the LSA is just the secrets location on your operating system. Key Vault is where your secrets are stored inside of Azure. Effectively, that means if an attacker is in your environment and you have a cloud presence, your attacker is going to want to get to your Key Vault, because that's where your secrets are stored. So you're going to want to use very tight role-based access control to administer your Key Vault. And the same privileged access concepts that we talked about above are definitely going to apply here. You want to think about that, right? Do I want my productivity machine accessing Azure to do specific administration, or should they really be doing this from a separate machine? Now, in a true non-on-prem scenario, or maybe a ZTNA type scenario, it'd be really hard for them to jump. They'd have to fish the admin directly. There might be a lot of workarounds to actually prevent lateral movement. And so maybe I can get away with not having the pause-saw concept, or I should say there's at least a lot of other mitigations in place that might make things a little bit easier, but you need to think about that from a design standpoint. Some of those mitigations come really from this next piece, right? Enable conditional access without a banned MFA and PIM, with those the ability to create access and create keys. And I would probably require it anytime you're using it. That'd be me personally. Keyword out of band, a certificate via smart card or something gets inserted directly into your PC. That's not out of band MFA. The attacker can swipe the private key right off of that certificate and reuse it. Does you no good. Versus the phone, the authenticator app that goes to your phone, that's a direct push HTTPS to your phone. It's a tunnel. The attacker would need access to your phone itself. Effectively, they need to at least put a gun to my head and make me put the prompt in, something along those lines, right? It's a lot harder for them to do that, or they need to, I need to actually be an insider or something along those lines. Control access to your run as accounts via Azure role-based access control or key vault access policies. So think about this point, the accounts are stored up in the Azure Key Vault. You can now control who actually is allowed to use those keys. Now with back to your SharePoint farm account, well, that's probably not a good example, maybe your SharePoint Align at this point, but back to some random run as account that you have to distribute for whatever reason. You can decide that not only is SCOM distributing it, right, you also can decide that that run as account can only be used on the specific machines that SCOM's distributing it to via Azure policy. That's kind of nice. It's an additional check and balance. So those 3 bullet points are probably the big pieces that I would argue, but you've also got some network layer security that you can add in there as well. HTTPS and TLS to prevent an attacker from potentially reading this as it's going over the wire. There's other network security features like firewalls and that kind of stuff that can come into play as well that you can use to help secure access to and from your key vault. But that's another piece that comes into play specifically with SCOM managed instance and how you want to secure SCOM managed instance. With that, going to the Q&A. Obviously, this is a pre-recorded session, so I don't have any questions right here now to answer, but I will be here to answer them as a part of the SCOMathon presentation. And I would also like to say thank you from all of our sponsors, and I hope everyone has a very good conference.